Now, before we jump into solving this system here, notice something about the relationship between these two equations. Notice this. From the top to the bottom, this is 1/2, 1/2, and then not 1/2. Or if you like, double, double, not double. Now, if you remember when we were graphing lines, we had this kind of a situation, and if we like multiple, multiple, different multiple, those lines were parallel. If it was multiple, multiple, same multiple, then they were coincident. So we've got half, half, not half. I'm expecting these lines to be parallel. So if they're parallel, something interesting should happen here. Let's see, I'm going to name these. That'll be equation 1. This will be equation 2. And I think a good plan here would be to solve equation 2 for x. I can easily solve for x in equation 2, right? All I have to do is subtract the 5y. No fractions. Pretty simple. Let's do that. If we do that, we'll get x equals negative 5y plus 9. And now I'm going to substitute this into x in the top equation. Doing so, we will get this. 2 times x. That x is negative 5y plus 9 plus 10y. That's equal to 5. Let's multiply through. We'll get negative 10y plus 18 plus 10y equals 5. And now look at this. Negative 10y plus 10y is 0. So the y's are gone, and we get 18 equals 5, which of course is false. And what that means, when we eliminate all the variables and get a false statement, that means we have parallel lines. Parallel lines don't intersect, so we're going to claim there is no solution to this system of equations. That means that there's no ordered pair, no x and y, that solve both equations at the same time. Now, before we jump into number 5, just look at those equations and look for any relationship. Look what we've got. Negative 6 to 3, 2 to negative 1, 4 to negative 2. It looks like we could take half of this and negative. Half negative, half negative. Or if you like, how about if you multiplied everything in the second equation by negative 2? That'd be our multiple. Negative 2 times, negative 2 times, and again negative 2 times. So we have a multiple, same multiple, same multiple, all the way through. So what we're expecting here are coincident lines. Here's equation 1. Here's equation 2. And I think the plan could be to solve equation 2 for y, because I can do that without getting any fractions. So if I subtract that 3x, I'll get negative y equals negative 3x minus 2. And then multiply or divide by negative 1. We'll get y equals 3x plus 2. Now that we know what y is, take that value of y, 3x plus 2, and substitute it back into that y up there. And this will give us negative 6x plus 2 times y, but this is the y, right? 3x plus 2. So we'll get 3x plus 2, and that's all equal to 4. Distribute, we'll get negative 6x plus 6x, so I can see the x's are gone. And then plus 4 equals 4. 6x plus 6x is 0. So we end up here with 4 equals 4, which is a true statement. Now what we've done here is we've eliminated all the variables and we're left with a true statement. That means that we have coincident lines. And coincident lines just means like one line is right over the other line. They just blend together. And that means we have no unique solution. So here's a system that has infinitely many solutions.